out, and we install a CT here, a current transformer here, and we bolt it, and we weld it sometimes or bolt it with the same material. So if this thing is copper, so this CT primary would always be of copper, and then the secondary voltage is secondary side is then supplied with high voltage, which is then checked through an ammeter with low current. So high voltage, low current. Its function is already described. It reduces the power system current to lower value for measurement. So on the input, if we have 1000 ampere, on the output on the same CT we would be having let's say we had 400 by 5 CT, so 1000 multiplied by 5 divided by 400, so this is 50 by 4, 12.5 ampere. So on the input, if we have 1000 ampere, on the output we will have 12.5 ampere. So this can be measured easily with a simple household ammeter even. Okay, the insulation of secondary is very important because secondary is of higher voltage, and it permits and it insulates the primary from secondary as well, because primary is having very high power but secondary is having this much ampere, so we can use lower ampere for low power. So it is used for sampling out 12.5 ampere from 1000 ampere. So it insulates primary circuit from secondary by not touching electrically. Okay, permits the use of standard current rating for secondary equipment. So standard equipment can be used for secondary side because the volt current is now lower. Okay, this is the construction in which we are having two types of this CT, bar type and wound type. So bar type we have already discussed it, sorry. In bar types, what we are having this wire which is a bus bar. So bus bar is then surrounded by a core, and this core is surrounded by the secondary side coil. Okay, in wound type, both the primary and secondary are wound on a core. So this one is used for a bit lower currents and voltage. So normally if you have this one, this would be used for sampling out currents for low measurement. So we use this type in our final year projects when we take out current reading from 400 volts and let's say 30 ampere bars, not bars, just wires. So we put this thing around a wire and we touch this thing with one side of the wire and we touch this thing with our measuring side. So here we have some microcontrollers etc. which are used for conversion of these signals to meaningful results. Okay, so this is the wound type. Okay, if we check the equivalent circuit of this CT, so we have this all the CT arrangement in here. So this is our CT, but we consider its internal resistance and impedance. So if we have its internal resistance, that resistance would be felt on the output side, so that's why it is the secondary impedance which is seen here. ZE is the secondary excitation impedance. So this is important if we want to excite this CT from this side. So if we excite this CT from its secondary side, what would happen? This secondary voltage would develop a voltage on this side. So why a voltage is developed? A voltage is developed because it shows some impedance. So that shown impedance is represented by this outside ZE. We do not show it here, so we show it here. Okay, this impedance shown will also have an excitation voltage here, and the total voltage of the terminal would be experienced here. So we give total voltage, it drops in the secondary impedance circuit, and resistance circuit, and then the rest of the voltage is appear. So this E is the secondary excitation voltage. So this is a bit simpler, that terminal voltage is less than excitation voltage if we are using input from this side, and vice versa, if we use this from this side, then Vt would be greater. So Vt would be then terminal voltage from primary, because we are exciting it from this side. Okay, N is the turn ratio, and normally turn ratio is 1:x. Okay, sometimes it is expressed in amperes. So in amperes we are having the input amperes divided by output amperes. So input ampere is, let's say, 500 and output is 5, so it will be 500 by 5. But this is the nomenclature for engineers, and this one is for the mathematicians. So 1:x is for N's ratio, and this one is for taking measurement when dealing with current. The safety measure is just one, that do not let secondary side open while the current is flowing in primary. Because of high voltage, the secondary will have sparks and it will get damaged. The secondary will continue to drive current. Why? Because it has very high voltage, and high voltage says that it has very high impedance, and high impedance would want more and more flux from this side, that I want to drive some current, I want to drive some current. Ultimately this circuit will get damaged, and this will also get damaged. Okay, it will produce high voltage across the open secondary, and this will be then have some high peaks which will break down the CT insulation. So insulation can be damaged. It is used for monitoring operation in grid and collecting data for current. So we already have some idea about it now. Moving on towards the potential transformer. Potential transformer collects voltage in lower value on the secondary side. So we gave it a high voltage here, and we get low voltage here. So definitely N1 and primary would be greater than N2, because more coils would have high voltage and less coil would have low voltage. So its current would increase. So current will increase. Okay, potential transformer is a step down transformer, because it step downs the voltage. This Vp is greater than Vs, and it has lower turns on the secondary side. So N2 is, and secondary is low. Okay, and the ideal transformer, when rated burden connected across the secondary voltage of transformer is equal to the turn ratio. So it says that if we are having a lossless transformer and we connect a very normal load with it, so this V out would be equal to N out divided by N in multiplied by V in. So it says this thing. But actual must have some error in voltage due to the resistance in the coils. So for that we will study this diagram again, that we will have some resistance on the primary, some resistance on the secondary, and it will have a bit different Vs than Es. So Es will be higher, Vs would be lower, Ep would be higher than Vp, lower than Vp. Vp will be higher because this is the input. Here we will have some losses, and then it will appear here, and we will have again some losses, and it will appear here. So this is the loss circuit. This is the reactance of the primary side, and resistance is the reactance in it, and these things represent the leakage. So sometimes transformer has some leakage currents, which will be then studied in this portion. Okay, so this was the story of the potential transformer, that it converts some higher voltage to lower voltage. Now potential transformer, as the name suggests, it is used for calculating the potential, the voltage. So for voltage measurement, if we want to measure voltage of a circuit, we connect a voltmeter in parallel with it across the resistor or across this thing. So if we have let's say line 1 and neutral, and we want to calculate the amount of voltage it is having, so we will connect our PT here. So this will be our PT. So that's why the PT connection on the primary are here, and it is having more coils, and this is high voltage source. So if we have a 3-wire connection, this is, let's say, live 1, live 2, live 3, and this one is, let's say, neutral. So N, V1, V2, V3. So for calculating 3 phase voltages, we would need 4 or 3 CTs, PTs, because the first PT would be installed here, the second would be installed here, the third would be installed here, and the fourth would be installed here. So we can have more and more PTs, because potential between 2 wires will always be different. So we can have V1 2, V1 3, V2 3, and V3N, and V1N, and V2N. So these are different connections which we can make with these CTs. Whereas there would be 3 CTs always. Why 3 CTs? Because there are 3 lines and 1 neutral. So CT1 would be here, CT2 would be here, CT3 would be here, and neutral does not want any CT. Okay. So this is about the connection of potential transformer. Types of potential transformer include electromechanical PTs and capacitive. Electromechanical are similar to the step-down transformer because there is no connection between primary and secondary electrical, and it is just stepping down the V1 to V2. So V2 is less than V1 for PT. Whereas if we see this capacitive PT, so it has capacitance divided at the front end. So let's say we are having 200 kV. We divide this across similar capacitances. So what happens? This is, let's say, V1, V2, V3, and V4. So if we then make connection from this, it will be more lower, because V is equal to V1 plus V2 plus V3 plus V4. So when we are having higher voltages, what we do, we first use this capacitive divider thing, and after that we use one capacitor and then install some PT with it, so that PT becomes capacitor PT, CPT. So CPTs always have capacitances in here, and if we apply voltage here, so it will be divided. Okay, that's why it is used for higher voltage. This one is used for lower voltage, because it cannot divide the voltage, and all the voltage will be converted to here. Okay, construction of PT is almost similar to CT, but mechanically it is a bit different, because the PT is having output of 200 to 300 volt ampere, so cooling is not a problem. Whereas in CT we use it for high current, so high current require high cooling. Insulation is used for the primary side, because primary is higher voltage. In that case, in CT, the insulation is for secondary side. The mechanical design is that it has 2 sides instead one. If we check the design of CT, it has this thing. So this is one thing, and in CT we are in PT we are having 2 these coils, because we are having the connection of 2 wires for it. So we try to find the potential difference between 2 points, so that's why we are having 2 connections. In CT we have only the passing of 1 wire, so that's why this is CT, and then we are having the measurement box in the bottom. So here we will have terminal connection in the bottom. Okay, if we check this thing, and the function of PT and CT is defined in here. For CT we are having this coil which is connected on this core, and there we are having some resistance for creating some voltage signal, and then we measure this voltage. Whereas in PT we ground one side and we connect one side to this wire, and then we just measure its voltage. Okay. Causes of error in PT are the drops due to internal impedance, which we studied in that circuit, and due to some leakage currents and voltages. So now summary. So we studied current transformer and voltage transformer. I mean, we tried to understand how it measures the signals and voltages and currents. And then we studied the phenomena that CT should not be kept open, and also we checked the potential transformer measurement voltage and provide isolation from high voltage. So we check these two properties of PTs. So if we check this circuit, we are having a high voltage, so the CT is connected in series with this load, and the PT is connected in parallel with this load, and then this is PT giving us voltage, and this is the CT giving us current. So low voltage would be calculated here, low voltage will be calculated here, and high voltage, high currents are available here. This load can be an entire CT, so do not consider it just a resistor because it's a very high voltage. Okay, so this is all about the CTs and PTs. These CTs and PTs are used for conversion of voltage and current, so that we can measure it with ordinary ammeter and voltmeter. So CT and PT are used for this. We cannot measure directly 1000 ampere with an ammeter because ammeter will get damaged. So we use CT and PT for converting it. Similar for voltmeter. Okay, thank you. Thanks for listening to this entire lecture. I hope you people have more idea of this current transformer and voltage transformer after going through this video lecture.